Welcome to problems that are specific to multiplication. We'll have some applications of multiplication later on, but in this video, I'm going to look at a few practice or example problems for you from 1.3. So, multiplication. Multiplication is essentially repeated addition. So, I have my textbook here, and I have your key, answer key, your solution guide. So, I'm only going to do the even problems, which you don't have solutions to. You have solutions to the odd problems as a resource. Again, do your best when you do these problems, the odd problems that are assigned, and I will do what I can. I'll do what I can to provide you with as many examples as you need, and I'll use the even problems. So we look at number 2. Actually, let's look at number 2 because this is number 3. But if we're looking at number 2, the question is, what is 3 times 4 if you're going to put it in a number line? So we're going to look at the system they use. If you're looking at 3 times 4, 3 times 4 would be, one way you could write that is 4 plus 4 plus 4. So that's 4 3 times. And so when it's 4 3 times, we can go on a number line and go from 0 to 4. And then from 4 to 8, and from 8 to 12. So just depicting it from a number line, that is one way that you can show your work for the problem. So you would be doing number 1 from this section, and you can show your work. Okay, let's go on to another example from a different section. Let's look at number 6. Now, in this section, you learned about different properties of multiplication. We have the associative property of multiplication, just like we have the commutative property of addition. So we have the associative property, we have the commutative property, and we have the identity property of multiplication as well. So notice that multiplication and division, we have certain properties of real numbers that we use in doing these problems. So let's go ahead and look at the number 6. 5 times 8 is equal to 8 times 5. Let's just call these CP and AP. So this will be the commutative property of multiplication because you've moved the location of the 5 to where the 8 is and the 8 to where the 5 is. So you have rearranged them, and that's going to be equivalent. So that's the commutative property of multiplication. Number 8, we'll just look at a few of these. The next problem is asking, how about 4 times 6 times 5? And if we have the parentheses that way, is equal to 4 times 6 times 5. Now, the parentheses has shifted. So the numbers remained where they were. 4, 6, 5, 4, 6, 5. But the parentheses shifted. So that's the associative property of multiplication. How about number 10? 8 times 7 is equal to 7 times 8. What do you think about this one? The numbers moved around. The commutative property of multiplication. Number 12. When you have 8 times 6 times 4 is equal to 8 times 6 times 4. Did the numbers move? No. That means we use the associative property of multiplication. And then finally, we look at we'll look at 14 and 16. Number 14, what do you do when they ask you 39 times 1? For number 14, we are looking at one of the properties I mentioned earlier. I wrote it in the form of just calling it the identity property of multiplication. So with this one, for number 14, we have 39 times 1 is 39, and for number 16, 44 times 1 is 44. Both cases are dealing with the identity property. Your book mentions it slightly differently. They say the multiplicative identity property, or I say the identity property of multiplication. The multiplicative identity property, that's fine. You can use that for this section. So we've looked at a few practice problems. We're going to go down now, and we're going to look at the next section, which simply, this is from number 17 to 28, and it has to do with multiplying numbers. Now, here's the thing. If you went through whatever textbook you went through from elementary school all the way to pre-algebra as a course, which is usually offered in 5th, 6th, 7th grade or 7th grade, you would have multiplied things like 700 and, or actually 907 times 6, which is number 19. You would have done these types of multiplication where you set it up like that and you multiply through. So please, I recommend that you just do the problems that are assigned from that section by using the skills that you've learned for multiplying. And that's actually the same for number 29 to 40. You're just multiplying using the principle where you multiply 6 times 7, you have 42, you put a 4 up there. 6 times 0 is 0, you bring, and then you have the 4. 6 times 9 is 54, so you have 5442. So just use your skills of multiplication, and that is what you would need for those problems. For number 41 to 44, you're dealing with a set of arrays and you're counting how many arrays are, or how many boxes exist or objects exist within those arrays. You can just check whenever someone gives you a certain number of things. So if I give you this, so if someone gives you this, you can take these values and you say there's 4 of them, and then you can count down and you can say there's 5 of them. So you literally just say 4 times 5, and that will give you what you need for the circle or the shapes I drew here. Instead of counting them one by one, I can just use that principle if it's just a well laid out shape, in a well laid out shape like a rectangle. So basically like finding the area, which leads us to the next section where we give you the length and the width. So from number 45 to 52, we give you the length and the width. Can you find the area? Can you find the perimeter? So let's do both of those. Let's pick out some problems. Number 46. So this should help you with number 46 to 52. Again, the idea is that you watch these videos, get some examples that you can use to then do the problems that have been assigned. Number 46. The length is 48 inches and the width is 24 inches. I recommend that you practice, use this as a warm-up for your multiplication, 48 times 24, and the rest you can follow the steps from your multiplication skills. So that's what you would do for number 46, because the formula for area is length times width. So because the formula is length times width, you can use the formula of 48 times 24. How about if I told you to find the perimeter of this same shape, which would be the same set of same type of problems you'll be doing in the next section? What you do is you have 2 times length plus width. That's one way to look at it. So you could just say 2 times 48 plus 24. You add those two numbers together, you multiply by 2, and that is the perimeter of the shape. The next section, they give you a few things to look into. They say a set of beads costs 50 cents per dozen. What is the cost of 19 dozen sets of beads? Let's go back. That's 53, so you're doing that one because you have the odd problem. But let me look at number 54. A set of beads costs 60 cents per dozen. So they've told us they cost 60 cents per dozen. Okay? For each dozen, they cost 60 cents. Now the question is saying, what is the cost in dollars of 7 dozen? So now you're looking for 7 dozen. So imagine if it's 60 again for 1, for 7, we will then multiply the 60 times 7. So 7 times 60, so we get 420 cents or $4.20. Okay? So what do we do with these ones? We read the question, we understand what they're telling us, and we apply reasoning to the question. We apply reason. So we look at the fact that there's 60 cents per dozen, and there's now somebody comes and says, I want to buy 7 dozen. Well, you take that 60 cents, you do it again, you do it again, you do it again. So 7 times. That's how we get number 54. Number 56, if a math tutor worked for 46 hours and was paid $11 each hour, now that's pretty good pay for a math tutor that maybe, for example, might be working in a math lab at a university. I remember I used to do that as a student, and they pay about $11 an hour. And this tutor 1 week decides, I'm working 46 hours. I'm going to work hard. how much is this tutor going to get at the end of the day for that particular week of working hard? Forget about the taxes for a second, which of course is the tax details that we can look into, but just how much. You take 46, you multiply it by 11, and that's how we do number 56. So you have 46 hours, and each hour is $11. So you multiply that by 46 hours, and that will give you the answer that you need. Number 58, there are 12 eggs in 1 dozen and 12 dozen in 1 gross. How many eggs are in a shipment of 11 gross? So you have 12 eggs in a dozen, right? So you have 12 in 1 dozen and 12 dozen in 1 gross. So now they're saying in a shipment of 11 gross. Well, we have to multiply that by 12. And then we have to multiply that by 12 again. And that will take us to our destination. Very good.